Acidification of on land seeps into the earth, where it is stored in the aquifer and moved to the stream and lake. The soil permeability, moisture content, vegetation, and precipitation intensity influence infiltration. The water table height indicate the volume of water in an aquifer, precipitation volume, and soil permeability affect the amount of water stored in the aquifer. Large particles and with large space allow more water and leading to higher infiltration. Next, for the objective to determine the feature of water infiltration rate into field soil. The infiltration rate of the water decreases sharply over the time after initial water application. To convert this into the incremental infiltration velocity for the inner ring and annular space, the following equations are used. Inner ring, incremental infiltration velocity time interval, initial area of the inner ring, and volume of use to maintain the constant head in inner ring centimeter. The annular space between the ring is calculated using the same formula, but the inner ring infiltration rate should be used if the rate difference divide flow constant rate discrepancy. This formula are used to calculate the volume of water permitting the inner ring and annular space at a time interval.
Part of methodology infiltration rates. They are involved with two things, which is equipment and procedure. The equipment, which is inner and outer ring, driving plates, hammer and buckets. The procedure, which is set up inner ring, cutting side down, placed on the ground, drive plate position on the inner ring, ensuring it fit between the pins. Hammer, insert the inner ring about 5 cm deep into the ground. Outer ring placement, outer ring center around the inner ring. Drive plate placed over the outer ring, and the outer ring is insert 5 cm into the ground. Preparation for infiltration. Drive plate removed, cleaning inside and outside the inner ring to prevent interference during infiltration. Water level marking, water level in the ring marked at a depth of 10 cm. Infiltration process. Water pour into the outer ring until the depth is 10 cm, tracking down to 5 cm. Water simultaneously pour into the inner and outer ring until reach 10 cm depth. Infiltration rate measurement. Stopwatch used to measure infiltration rate every 30 seconds. Continuous measurement until consistent reading are obtained 3 to 4 times.
Okay, so next is result and calculation. So my group got the reading for inner rings is decreasing, and the calculation for infiltration rate we got from 100 divide by times, and infiltration capacity, the calculation we got from 100 minus with inner rings. Okay, so for this experiment, my group got two graphs, which are infiltration capacity versus time and infiltration rate versus time. For the infiltration capacity versus time, we got the graph is slowly increased, but infiltration rate at the beginning, the data is increasing, but then it's decreasing and not constant.
For discussion part, the experiment shows that soil infiltration rates are highly dependent on soil types. Dry soil is dirt that doesn't appear to be a dam. Dry soil has a higher infiltration rate than wet or saturated soil because it contains more porous gaps and holes, allowing water to fill quickly in the space it left. As a result, dry soil takes in water faster than wet soil. Unlike moist and saturated soil, dry soil has the most excellent infiltration rate. Compared to saturated soil, infiltration happens more quickly in wet soil because it already contains some water. For this reason, wet soil takes longer to absorb water than dry soil. Compared to wet and dry soil, saturated soil, which is already reasonably moist, has the lowest infiltration rate and is akin to an impermeable layer.
Now I will begin the part of conclusion in this lab infiltrations. So we can see clearly the result of the infiltrations laboratory depends on the water and the humidity of the surrounding environment. So that is make us too difficult to get the result and the data analysis. So the infiltrations rate reach a constant measurement starting from the 1780 second until the 2020 second. So the infiltration rate is affected by the depth of the soil. So as we know, dry soil has a faster infiltration rate than the wet soil and the saturated soil. So the objective is to determine the feeder of the water infiltrations into the field soil. So was achieved in these experiments. So that is the more important thing in this laboratory applications that we need to focus is the infiltration rate must be carefully monitored and controlled. This because there will be change due to the unstable factor like the depth of the soil will given the different unit and different value of the infiltrations. So and in addition, we need to know the precaution step is ensure the position ice is perpendicular to the scale of the ruler when taking the measurement reading. It means that when we pour out the water into the inner ring or outlet ring, we need to make sure our ice is made in the right way and the right angle to which is the perpendicular to the ruler, so we can avoid we occur the error when we get and take the reading. So the third step is ensure and prevent the spread of the water to outlet ring when water is poured firstly into the inner ring. As we know the procedure, we need to fill up the water in the inner ring before we fill up in the outlet ring. So it means that when we pour out the water, we need to make sure the water does not spread out in the outlet ring. So they will occur and affected to the reading and the result. So that is the important step we need to focus to avoid the error in this experiment.